Hello, everybody, and welcome to episode 6 of SpaceShooter. It's in the morning, and I'm not really that sporty or whatever you call that awake, but I'll do my best. So, this is the video that I promised, in which I'll explain what the code means. So, I might have this every 10 videos. And this whole series probably wouldn't be 10 videos long, but yeah. So, in our main class, this is where we're gonna start because it's our main class. This is a line of code that nobody really is interested in. This is the width and the height of the game. So if you went ahead and changed this because you were just you would have a very longer game, and the stars would be also very strange. And also, the game also seems to be slower if you made it less. Well, the game becomes smaller. And if you made it to 0, this happens. What happened? So yeah, that happens. So keep it at 800 or something manageable. The height is exactly what it is. The height. You get a flat screen if you put it at 0. You get a normalish screen if you put it at that. And you get the this sized screen if you put it like this. But it is a 600 because it's pretty good at 600. Not too big. Yeah. Okay, so the size. Now, the thread. Basically, if you don't know what a thread is, it is an object that you can simply give a runnable to, and it will just run the runnable's run method. Makes sense. It runs it as long as it feels like it, I guess. Just runs it. This is so we could also just put this here. Game dot equals new game, and while true dot and we could just while I don't know. While that happens, we could do this and it will do the same exact thing. and also I'll do the same exact thing. So you say, why the heck did we use a thread when we could have done the exact same thing in the main method? Well, the reason is because that's flashing a flashlight camera at me for some reason, I don't know. It is because later in our game there's a possibility that we might want to add more threads. And so we want more threads. The reason thus is that we might need like something that runs along our run method. Maybe we have another window, like another game window, but it needs to also have its own run method. So this allows us to have that. Okay, and running is pretty obvious. It's just when the game's running, it's true. When the game's not running, it's false. Object handler. It is our object handler. Where is it? No, that's the wrong thing. Object handler. In this class, we simply handle all the objects. It stores all the game objects in our game, and every time you call tick, it just loops through the game objects and call tick. And every time we render, it just loops through them and renders them. We can also add and remove objects from the game by calling add and remove. One thing. I think that this is actually the most efficient way to loop through things, because so here's how some people sometimes do this. For int I equals 0, I is less than things dot size and I increments, and then they just call things dot get I dot tick. Now this is fine, as you can see here, it's perfectly fine. But once your game gets like a whole bunch of objects, the first way would be faster and thus better than the second way. The reason is that this just loops through the whole thing once, and it just gets the thing at every level, the game object at every level, and ticks it. But this loop, it just loops through an int. So, and then things, a linked list actually has to get to there by saying, so I'll just grab out image editor, just maybe it's better. Like, okay. Okay, so Windows, what a pencil. So in our first way, it just, so 1, 2, and 3. So this is our list, and let's say we do this with 3 game objects in it. So in the first way, it comes here and says, okay, this is the first one. I'll just stop here and do whatever the loop body does, and call this one, assign it another reference called GO. And it does the same for every other one, and thus it's actually just one loop. Okay, but in the second way, it loops through a number. So it's like 1, 2, 3. So loops through this number, and then once it gets to this number, it then calls the things, our linked list, which is a list with G1, G2, and G3. Sorry, I don't know how to write using GIMP, so it might be horrible. It comes here and says, okay, I'll find the first. So, oh, here's the first. So always fine, but once you get the other one, it has to come here and say, oh, is this the second one? No, it's not the second one. I'll come here. Okay, this is the second one. So you see, it had a little dip in performance right there. And the third, 1, 2, 3, same thing. 3 dips in performance. So once it gets to be like a whole bunch of game objects, the dip in performance will be noticeable. But this, the dip in performance will be less noticeable. Even though at some point there will be a dip in performance, like once you have like a million objects. That's a whole lot to keep track of. So yeah. So that's why we do not do this, but we actually do this. Same for this one. It's the exact same logic. And the add simply adds and removes. Okay, our key input. What does it do? Well, it is a whole bunch of code that I managed to put together actually. So it has its own player, the player that it controls, actions, basically the keys that it uses to control the player, the action done, which is just if the key was pressed, because we don't want to like put in the code inside these methods. It'll just be sometimes fast, sometimes slow. It'll be not very, how should I say that, consistent, yes. So that's why I put it in a tick method. And the tick method will consistently called every 100 times per second. And that's not too bad. I mean, we could have made it twice, but there was no point. You can't really see the difference, except the whole game just goes faster. And the handler, object handler, that is just to add the bullets. There wasn't really a need for an object handler. I guess we could have like did something to it, so we didn't need to store object handler, but that's beside the point. So in our constructor here, it sort of just constructed by doing all the normal stuff. Like, the only thing special about it is just it checks whether actions dot length equals 5. So because our actions has to have a 5 length. And that's just an ordinary constructor. And here is just a constructor that calls this constructor because it probably we probably don't want to like have to type all this, and every time we want to make a new key input, even though we could have done this, but that's only because we have only one player and one key input. But once we get to like a whole bunch of players and a whole bunch of key inputs, we could save some typing, like one line of code, and that we put right here. And the users, let's say we just for some reason sold this package to some users who wanted to like be able to play around with this. They will be then able to have greater speed in using this. The key press method is called by key adapter actually, so we don't have to worry about how it does it, but here's what it does when it gets key events. So it just gets the key code, which is basically the number that the key stores, and then actions. One, if that was true and stuff like that. So if key equals action 0, which is W in our case, which will be the up button, then action done 0 will be true, and so on. Key released, same thing, except it will be false because the key got released. And the tick method, if action done 0, do this. Just set velocity. Do this. And that. So if it's 0, then go up. If 2, then go down. And if none of them, set it to 0, stop. And the same thing goes here, except it's left and right. And this is the final one. It's the bullet shooting bit of code, and it looks a bit huge, but it's not. It just sets a new bullet at 0, 0 because there was no other place we could actually put it. And then because we didn't know the width of the bullet yet, so that was a problem. So we just set the bullet, create the bullet object first, and then we set the position which requires the bullet's width. So that's the reason why we put it in separate code. And then of course I have to add a bullet to the handler to the game, and action 4 equals false. That's just so we don't, like, if those are not true, we'll have like just craziness. You'd be like shooting trillions of bullets, like 100 bullet per second. 1, 2. What just happened? One, 2, 3. That was like 100 bullets. So we didn't want that. We don't want 100 bullets per second. So this prevents 100 bullets per second. So that works. And finally, a buffered image background. It's sort of obvious what it is. It's the background of stores. You could also, let's just make it not And we have a giant player here for some reason. We never understand. Or even bullets. If we so felt like it. So we get like a huge bullet here for no apparent reason. But we pick the background stars because we're in space, so that makes sense. And then into the constructor. O-handler, we set O-handler to an object actually now. We create a player, and a player is just a game object, a normal game object, except for its tick, which is simply this code, which gives us a fake X, fake Y, predict what will happen to it later. I don't even know why would we need this. Hold on, X plus equals. You know what? We'll fix that in a later video. But for now, just leave it like this. This is what will happen if it moved, and it just checks whether it's moving right, and then so it just says, okay, it's moving right. It's not moving left because it's moving right. Otherwise it's moving left. It's not moving right because it's moving left. Otherwise, it's not moving right or left. And the same thing applies here, except for up and down. And this is this bit of code. So if velocity y, velocity x equals 0, then return that. And facing right is the simplified version of this. And the right here is just a bunch of code that actually just means, okay, is it facing like down? If so, return this. Otherwise, just if it's facing right or left, just return that if it is. So yeah, that's simple enough. I mean, down, yeah. So, back in the game class. We add the player to the O-handler. Then we assign the player, the input, to a new key input with player in O-handler. We add key listener as to input so it can actually listen to the keys. And then we send the background of stores to the background. And we make a new window of size width, height, SpaceShooter version 0.01. Actually change that to like, it's pretty advanced right now, 1.5. Yeah, that's give it credit, and give it this. And that just means do all this stuff, which is simple enough. Just make a new JFrame, set the default close separation. That means if we click exit, the X button, like the X button right here. If you're using some other operating system, it will be here, like most ones, it will be here, but in Linux, it's here. It stops the program. If this were not true, then the program will still be running, except it's just going at crazy frame per second. So that's why we set that, so we can easily exit the program. Set the preferred size, minimum size, maximum size, just sets the size basically. Set resizable. We don't want it to be resizable. if we put it as true, then we would be able to resize the thing. But as you can see, it's sort of weird now. Like, ew, what happened? Now you can just smear across the screen because we don't erase what happens here. So you can just smear across the screen. This is what actually the bullets actually do. Once you leave the screen, to just do this. Just smear. So yeah, that's why we don't want to set it to resizable. It's a good reason for that. This happens basically, and nothing bad happens like this. But once you leave the screen, all this random scary crazy stuff happens. So that's why we don't set it to resizable. That's why it's false. So once our users play this game, they won't see the crazy stuff happen. And then this beta code right here just says, I'm not gonna set it relative to anything, which is just a synonym for set it at center. Add game, because we want to be able to see the game on the frame. If that were not the case, there'd be no game on the frame. And the frame that's set visible to true. If it was false, you wouldn't be able to see it. And that's not really good. Yeah. So, in our start method, it just checks if it's running. Well, if it's not running, the only point in running start is just because we want to make it run. If it's already running, then it doesn't run this whole method at all, because why would you? It's already running. How to start when it's already running? So basically you can just do some starts and stops. And yeah. And then in stop, also it just creates a new thread and puts game inside the thread, so it can run this thing. Running becomes true and we can start thread now, which basically makes it start running this thing. And stop, it's just running equals false because it's no longer running, so you can just falsify it. And we just do thread.join, but it requires a try catch because it might blow out an error for no reason. So that's stop method. In run method, we request the focus. We don't actually need this here. We just request the focus. Otherwise, we have to click on it to make it respond to us. But if we do request focus at the beginning of run, then we don't have to click on the game for it to respond on us. Last time is basically the measure of the last nanosecond time. Amount of ticks, it can be renamed per second. Just amount of ticks per second you want to run. Basically text once and render once. And yeah. And double nanoseconds is basically this number that I have no clue what it does. Delta is something that I also have no clue what it does. Timer is just the timer. It just like sort of times the whole operation. Like it checks how long this took and it's basically the number of time this whole one loop took, and that's what it is. Frames is what we just print out because we want to do. Would have totally ignored that thing. It still worked fine, but some people like to keep the frames to check how fast it runs. And long now, the time now is now. Delta plus equals now minus last time divided by nanoseconds. Something. The difference, I guess, last time equals now. And while delta is greater than 1. So delta is basically I guess, the last time minus now in seconds. Well, divided by this. So delta is like how many times you should run. Well, it's sort of hard to explain, but you see, delta is sort of checks whether amount of ticks has been reached and runs it otherwise. And frame is just the thing we print out, and that's the whole thing to check whether timer did something. And stop at the end of the while running, like running becomes false. So yeah. Well, this intake method input text then handle text just because we want it to be like better response, even though it'll be 100th of a second response speed. You can't really feel the difference actually. And render is just grab the buffered strategy of the screen, and if it's not, just like if it's null, that means if it isn't something, just create a buffer strategy and exit. And then graphics G equals BS at get draw graphics. I almost said get graphics, but get draw graphics. So basically it grabs the graphics object that is used to draw on the buffer strategy. We set a color, fill the rectangle so we can clear screen. We draw the background. We actually could have simply ignored the whole thing here, but we'll have to have filled the background with black. So you can see here that actually clears the places where the player went. So if we fill the whole thing at rounded black and save that, it'll do the same thing basically, because it's drawing over it. This is actually a more efficient way, but maybe we don't really have a graphics object thing. That could be a problem. In future videos we'll actually make it more efficient in that way. So yeah. And then we'll just render everything in the game. We dispose the graphics, so I believe it is an OpenGL based is a graphics library based object, so it's not actually completely coded in Java, I believe. So you have to dispose all the data that's in it, and we show the BS so we can actually see what it is. And then the main method, just new game.start. Okay, that was a long video, but I hope that you guys understand what the whole game does. If you do not, leave it in the comments and I'll try to explain what it means. So yeah. Leave a like, go and subscribe, and as always, thanks for watching.